Slurry's become quite a big issue over recent years. We see lots of reports of slurry pollution and how it's contributing either from direct discharges into water or more diffuse sources. We're here today to talk about the silage, slurry and agricultural fuel regulations, commonly known as SAFO. I'm going to go through some of the basic requirements that farmers need to do in relation to those regulations. Those will be around the nature and the type of stores, the type of engineering that's required for those stores. And not only that, I'm going to talk the importance about why we have those stores, what value do they have in terms of preventing pollution, and also enabling farmers to better use their manures and get the maximum value out of them and save the farmer money. Now, we all want the same thing, whether you're a farmer, whether you're an environment agency or the general public. We want to be able to manage this big problem. It can be a big problem. You know, a lot of slurry is produced on farms these days. We're getting larger and larger farms, and it's increasing the potential risk to local watercourses. And those local watercourses go on to cause wider problems further down the river network in the catchment. Quite simply, you want to be able to ensure that your slurry is stored in a nice secure container that's not going to leak and it's not going to fall over. You also want to make sure you have enough capacity, so you only spread at the right times of the year when it's not going to cause pollution. Now, what is the right store? Well, the right store is going to depend on your circumstances. It's going to involve elements of cost and the type of slurry that you produce and your management system. If you're using, for instance, a bedded system on straw, or you're using sand, all those kind of things and other things are going to influence the best store for the farm to maximise the value of the store and the manure that is there available for the store for use when there's a soil and crop need.
And the idea of this film really is to give farmers an insight on how to build a compliant structure that's compliant with the SAFO regs. We're inspecting a lot more farms now, and unfortunately we're coming across lots of structures that have been constructed fairly recently that are non-compliant. And the last thing we want farmers to do is spending hard-earned cash on structures that are non-compliant.
SAFO is about building the right store in the right place and in the right way to conform with the SAFO standards. It's also about ensuring that the farm has the right storage capacity to ensure that that slurry is spread only when there is a soil and crop need and without risk of causing pollution to the environment. When the SAFO regulations were introduced, there was an exemption for stores built before March 1991. The regulations only apply to stores that are newly built or are substantially altered after that time. Although there is an exemption in SAFO for these older stores, there is a mechanism in the regulations to bring these stores into compliance. Where the store poses a significant risk of causing pollution, that risk of causing pollution can also include a lack of capacity. So if a farm hasn't got enough capacity to enable them to spread their slurry when there's a soil and crop need, or when there's a significant risk of pollution, then the agency can require the farmer to build the required storage. And as soon as the farmer starts building that new storage, then the whole store comes into SAFO compliance. Okay, when you're thinking of building a new slurry store or substantially altering the existing one, you must inform the agency at least 14 days before construction begins. When you've contacted the agency may ask you further questions about the site and the soil conditions and its proximity to watercourses, land drains, etc. In talking to you, the agency wants to ensure that you build the store in the right place, in the right way, and the right type of soil for your system that maximises its value to you, but also minimises the risk to the environment. So it's a two-way process to ensure what you built is fit for purpose. There's guidance available to help farmers make the right decisions in relation to SAFO and to ensure compliance. One of those is Syria Slurry and Silage Infrastructure Guidance, commonly known as C759F. That's available from the Syria website. There's also a series of EA leaflets, which cover the various different types of stores that farmers may build, and in relation to soil testing. Those are hosted on the HDB website. The HDB website also hosts the Slurry Wizard that will help farmers calculate their slurry storage requirement. When you notify, the agency will ask for very specific information around the design and the structure and the nature of the materials that you're using, and to ensure that any guarantees for lifetime, because you've got to have a 20-year lifetime guarantee with maintenance, are all in place for the materials that you use. The agency also wants to understand the capacity of your slurry store. That's the amount of slurry within the storage period that your animals produce and will go into the store, and any rainfall that may go into the store that falls on your contaminated yards. So your collecting yards or from your dairy parlour. In the case of dairy parlours, it will involve the amount of wash water that you produce on a daily basis. Now, to help you with your slurry storage calculation, the agency has worked with HDB to create a Slurry Wizard. Now, that Slurry Wizard does that calculation for you. It makes it much more easier to do. It allows you to input your livestock numbers. It allows you to input your yard areas. It also inputs the area of the surface of the store and all the places where rain may fall and contribute to the capacity of that store. The rainfall is calculated on a worst case scenario over a 5-year period. It's called wet and average rainfall, because rain doesn't fall as an average. And the last thing you want as a farmer is to think you've got enough store, but it rains and your store overflows. That calculation is also built into the Slurry Wizard for you.
So the reason we have made this Sappho film is to give a really good insight of what a slurry store should actually look like that's compliant. We've given you in this film 3 examples, one of a cylindrical metal tank, another one that's an earth bank lagoon, which often gives us problems if it's not built properly. And also we have got a concrete store, a rectangular concrete store with a portal frame over the top of it.
Okay, so before you build a tank like this, you need to understand the characteristics of the soil to ensure that it can actually take the load being placed on it from this store, from the actual structure itself, and the contents when the slurry store is full. And to do that, the first thing you do is remove the topsoil and to check any soft spots. And if you've got any soft spots, they need to be made good before you lay the concrete pad on which the structure is going to be built. If you find weaknesses in the soil, then the pad's going to move, crack and break, and bring the whole structure down. Now, the advantage of a sealed tank is if you can't form an impermeable soil from an earth bank lagoon, then an above ground store like a sealed tank is a potential good option. It's also an option where the groundwater table is quite high, and also if you've got a limited amount of space. The tank itself is built on a ring around the concrete pad, and it consists of an alignment of galvanised steel panels, so they've vitreous enamelled, and the vitreous enamel protects the store from corrosion. The panels put together are overlapped and they're held together with bolts. Now the bolts are covered with mastic, and the joint and the overlapping joints between the panels are covered with mastic to form an impermeable seal. As you screw through the screw holes, the mastic then gets incorporated within the thread as well, maximising the impermeability within there. And the last thing is done is then to go over with runs of mastic around all the edges and seams between the panels to sort of guarantee the impermeability of the store.
The advantage of this type of slurry store is it's always extendable. So in the future, you can always put an extra ring in there if you need to for more capacity. It's always accessible from the bottom. So you can take off the bottom sheet or 2 sheets and drive in with the likes of a bobcat with a starter ring, and it's easy to cover. On this particular tank, we've got 2 large mixers going in, which can mix from 1 point up to 8,000 cube. Because of the size of the tank and the volume of thick slurry that's going to be in there, the farmer's chosen to put 2 in. So we have the likes of standard wall mixers. On here, we've got Harrier mixers going in, which is for bigger volumes of slurry to be able to handle.
Whether you're feeding the slurry in or out of the tank in the pipework, you need to have at least 2 valves 1 metre apart under SAFO. Now these valves shut off the flow and obviously open the flow when in use. 2 are used because if there's only 1 and that fails, then the slurry will escape. If you've got 2, you've got the added precaution there that if 1 fails, the other one will hold the slurry back and will prevent the risk of causing pollution. When not in use, these valves need to be locked. So again, if someone came onto the land and tampered with them, that's the last thing that you want. Farmers use various different stirrers to ensure they create an homogeneous mix of slurry within the tank. This store is incorporated with an inbuilt mechanical stirrer. So from time to time, perhaps when the store's being empty ready for spreading, the farmer will turn the mixer on, stir up the slurry to create an homogeneous mix, and a slurry of a consistent nature to then spread onto land. One of the big advantages of an earthbank lagoon is cost. It's by far the sort of cheapest of the stores to build, particularly if you've got the right soils in situ. Sometimes when you're building an earthbank lagoon, you'll strip off the topsoil and you'll find soft spots. You may find inconsistency within the soil, so it may be okay at one end, but it may become much more sandier at another. And where you've got that is the case, doesn't mean you can't have an earthbank lagoon. It just means that you're going to have to probably import the impermeable clay material in to make good that permeability, or you may need to actually line it. So if you can't achieve that permeability, then you're going to have to use a liner. Now the farmer had to send off the soil to the labs, so undertook 4 trial pits in each corner of this lagoon and 1 in the centre. That was then sent off for a particle distribution analysis to understand the amount of clay, silt and sand within the soil. You know you've got a soil that's got at least 20 to 30% clay within there. If you have less clay than that, then you're unlikely going to achieve the permeability. If you have more than 30% clay, then again you have problems forming the bank. So your sweet spot, if you like, is between 20 and 30% to achieve that permeability without any problems. When you return the soil, it has to be compacted. And you can't just put a metre of soil down and compact it. You've got to compact it in layers to achieve that permeability. So you'll probably put down layers of 15 centimetres to 20 centimetres, and each of those layers will be rolled to achieve the required permeability. Then you put another layer of the soil on and repeat that process until you've got the final depth that's required. You've got to have a freeboard of 3/4 of a metre, and what we'd expect to see on this slurry store is that you would normally put topsoil down to cover that zone. Another thing that the farmer would need to do with this store is to ensure that all around the top of the bank it's grass to maintain the stability. So particularly if you've got a dry and a wet slope, you want to create a camber at the top of the bank. they receive a grass camber on the surface, and it will be grassed down to that freeboard. And that also then, again, protects the bank against erosion because it's exposed. It's also important that for earthbank stores, you don't allow shrubs or trees to take root. You have to look out for burrowing animals, etc., because any rooting through the bank or any burrowing will, again, destabilise the bank. It will create potential pathways for leakage and seepage. And if it's severe, you could get a collapse of the bank as well. So if you have land drains, and they are within 10 metres of the structure, then they need to be removed or rediverted away. When you're actually also looking at slurry stores, you need to understand the water table. And the water table can have quite an impact on the management of a slurry store. You want to ensure that when you do your trial pits, you'll dig those trial pits on an earthbank lagoon at least 1 metre below the base of the store, because you've got to maintain at least 1 metre of impermeable strata for impermeability. You'll check to ensure that it has got that impermeability, and if it hasn't got that impermeability, then obviously you need to make that good, and you'll end up with a shallower, probably wider lagoon. There are options where you can actually divert the groundwater around the store, so you can put in drainage to do that. But again, that drainage needs to be 10 metres away from the outside of the store to ensure it maintains compliance with SAFO. Another good option for a farm store is a concrete built store, like the one in the background here. There are different types of concrete store that you can have. This one is a rectangular tank and is being made out of poured in situ concrete. So you minimise the amount of joints that you have and leakage points within the store. There are other types of concrete stores as well that are above ground. They are round, they're made by vertical concrete panels, and those panels are held together with straps. Now, the greatest pressure of slurry on a store is towards the base. So when these stores are constructed, you have more straps towards the lower bit, and you have less straps towards the upper part of the store. Before you build a concrete store, like many other stores, you need to ensure that the soil that it's going to be built on is stable. The farmer did that. The farmer did several pits, took some soil samples. Those soil samples were sent off to a lab, and they were tested to understand the strength of that soil. And the idea there is to ensure that the soil in situ is strong enough to take the bearing weight of the structure itself and the slurry within the store. To do that, you need to dig at least 4 trial pits, 1 in each corner, and 1 roughly in the centre of the slurry store. Now, if the soil is of a similar nature throughout the profile, then you only need to send off 1 soil for testing. If there's variation within the soil, then you need to have each of those variations tested as well within there. The store is around about 4,500 metre cube capacity. It's mass poured in situ concrete store. The farmer has around about 250 dairy cows and has quite a large lot of yard area. And the store will provide around about 6 months storage for the farm. That will enable the farm to spread the slurry when there's a soil and crop need and without causing a risk to the environment.
It's mainly concrete. We use a system where we're combining steel framework, which is combined into the wall, to sort of link it all to it. But we've been doing this for a long time, and we find it's a proven way to do. So it's robust. It will just take whatever they throw at it.
So when it comes to determining the right concrete base to withstand the forces on it and the concrete within the walls, you need to get the right concrete mix. There is guidance on the right concrete that you can use on these constructions in what's known as Syria C759F guidance, which is guidance produced by Syria for slurry and silage infrastructure. Concrete stores invariably use some form of steelwork as part of the engineering to hold the store up and to prevent it from collapsing. It's really important that that steelwork is on the outside of the store and doesn't come into contact with slurry. Slurry, and particularly if you mix that slurry with silage effluent, is quite aggressive and can corrode that steel, so over time it will create a weakness and increase the chance of that store failing.
This particular farm behind us is a robotic dairy unit, and it uses sea sand for its bedding. So the advantage of having a concrete store like this is that the solids tend to drop out in the slurry over the winter period, and that gives you quite a thick sludge in the bottom. And that sludge is very difficult to get out. You can agitate some sand and get it mobile within the slurry, but the bigger solids tend to drop out in the bottom. Or even if you do get them mobile in the corners and in certain areas in the store, you can end up with quite a thick sandy sludge. Like I said, that's really difficult to get out. So having this type of store allows you to drive in there and dig that sludge out and then spread that.
This store also incorporates the roof. The purpose of the roof here is purely to keep rainfall out. Rainfall is expensive to store, and having too much rain in your slurry increases your overall spreading costs. So it's normally cost effective to roof a slurry store.
This sort of structure kind of sits in the middle. It's more expensive than an earth bank lagoon. At the moment, you can currently dig an earth bank lagoon probably for less than 25,000, and that would service a reasonable size herd. This one would be kind of priced in the middle. It's not as much as a tin tank or a steel tank will cost you, or a concrete cylindrical store. It just kind of sits in the middle really, but it is very multifunctional.
The purpose of SAFO is to build the right store in the right place in the right way, and to ensure you've got sufficient storage capacity to contain your slurry. Now there's a win on that for the environment to ensure it's only spread when there is a soil and crop need and there's not going to be significant risk of causing pollution, but also applying it at the right times of the year means that farmers can maximise the value of the slurry that they produce.
There's lots of advantage of having lots of slurry storage. It gives you that flexibility to be able to spread when the soil and the crop requires it, and not probably during times when you really shouldn't be spreading, and it can give rise to diffuse pollution. Financially, having lots of slurry storage stacks up. The cost of manufactured fertiliser is really expensive at the moment, and this increases the value of stored slurry. So having slurry stored and good quality slurry without too much rainwater in it is really advantageous, and it's a fantastic product to spread.
There's lots of guidance out there for farmers to follow. One of those is what's commonly known as Syria C759F guidance, and that's guidance on slurry and silage infrastructure, which is available from the Syria website. AHDB also hosts a number of Environment Agency fact sheets which detail the engineering requirements and environmental requirements of the different store types and the kinds of soil testing that we'd expect farmers to undertake. Ultimately, when it comes to SAFO, it's about achieving a shared aim, and that is protecting the environment and minimising the risk of causing water pollution, something I'm sure we can all agree on.